Okay, so the next part of calculations that we're looking at is the method of joints and method of sections. So what these are used for is to be able to analyse the different joints or the members to discover whether they're in tensioning or compression. Okay? So the whole idea here is we can actually work our way around this drawing, but if you wanted to go a little bit quicker, the method of sections can actually speed up the process. So firstly, with the method of joints, and that's what this video is going to focus on, is that there are some rules. Right? The joint can only have no more than two unknown forces. Okay, in this diagram here, I can see there's one force going up, but when you actually come to the question, it actually gives us a second force there as well. So we've got force AO, and we have force, it's the upward force on the roller joint that hasn't been labelled. So looking at this force now, so basically to work this out, we need to actually sum our forces. We have this force coming down, which is 70 kilonewtons. We have this one going up, which is 50. Okay, so that, that allows us for pretty much 20 kilonewtons here in this member. Now, as you can see here, we have a nice little triangle that's happening. So we have 45-degree angle and we have this one here. And that's what we need to do. We need to, firstly, work out our FBD and what we need to actually find from the questions. And, trust me, I'm doing this in red so I know what needs to be found out. They are my unknowns. Coming up back to the question here. Determine the joints OB and OC and state whether they're in what their nature is, whether it's in tension or compression. So by writing this here, I'm going to remember. Okay, so now I've got this all broken down and I can start to see what I need to do. You can see I've drawn my first force triangle here. Now, all I need to do is sum the forces. So in this case here, the sum of all forces going up, I'm saying, is going to equal 0. Now I've made an assumption that this is actually going to go up, this force, which means it's pulling away from that joint, so this is going to be in tension. Okay, now I've made the assumption. I may get it right, I may get it wrong, but we'll work through to see whether or not I do. Okay, so like we've actually done here, force going up is 50, force coming down, which is the opposite, is minus 70, plus OB cos 45, okay? So I've got adjacent over, okay? So I'm just working it through that way. As you can see the math there, throwing that over the other side, negatives cancel out, and then I divide to get my answer there. Now, because this is a positive number, it means I've got my sense right. So this red line is correct, and that is the direction that the force is actually pulling on that joint. Now, I can do my second force triangle here, and again, I am summing the forces, right? So this actual triangle has both horizontal and vertical forces. I've skipped a step and didn't break it down, but that's what we're actually looking at, the horizontal and vertical components of this. So again, I'm saying that I'm assuming that the force is going this way, and I've stated that. And now I can start to do my calculations. 0 equals positive OC plus, because I've got the force going this way as well, which means it's pulling this way, OB cos 45. Okay, because I need to actually find this one here, and that's my OB. Now, as you come down, I've got a minus OC, which means that this is minus 19.99. What that actually means is that I've assumed this as being the wrong direction. Okay, it's the wrong direction. No harm, no foul. All I need to do is, in my answer, actually just turn that arrow around and state it as such. And because it's actually pushing onto the joint, that the nature of that joint there is in compression. Okay, so like I said, the whole idea of this is it's slowing down and breaking it down so we can see what we need to do. You can see that this, even in this free body diagram, it's starting to form triangles, and that's what we're trying to work out. Each of the member of the triangles, and that tells us the force that's actually acting on that joint. Okay. The sense is quite important, especially when we go further than this, to make sure that we get that right. But you just work it through until we get down to this.